Okay, so this is the first video, and so what we're going to do is we're going to talk about Chapter 1. So this is going to be beginning of Chapter 1, beginning of statistics. So this is basically going to be a lot of definitions and explanations, and then I'm going to do an example of how to interpret some of these as we go along, and how to pick these things out. So again, I'm going to do some writing on the board, but again, the way these videos are going to work is I'm not going to do a lot of writing out definitions. I'm going to tell you the definitions, and so you're more than welcome, and obviously I'm going to encourage you to pause the video to take down your own notes as you watch this. So I'm not going to do nearly as much writing as I would in lecture, okay? Since you can play this as fast or rewind and pause anytime that you want. So again, just keep that in mind, that I'm not going to be doing a lot of writing when it comes to definitions and things like that. So okay, so let's start. So as far as when we talk about statistics, statistics is by definition the collection, analysis, display, organization of data. Okay, so in statistics, the idea is we're going to use data to answer questions, and that's what statistics is all about. It's about understanding what data is telling us. Okay, so it uses math, but it's not really about the math, it's about understanding the data, okay? So statistics, again, by definition, is the definition that we're going to use is the organization, the collection, the organization, the analysis, and the display of data. Why? To draw conclusions about what? About a particular characteristic of a population. That's what we're interested in, okay? Statistics is all about making inferences or drawing conclusions about a population of interest, whatever that population might be, okay? Because typically, and you're going to find this out as we go on with more and more of the lectures in class and in the videos that I'm creating, is that in the real world, most of the time, we don't know what the population is. We know what we're interested in, we know the population that we're interested in, but we can't analyze the entire population because it's either practically impossible, or it will cost millions of dollars to do so. It's not cost effective. So that's where statistics comes in, because what we do is we're going to use a sample data, right? So we're going to gather what we call a random sample, and then we're going to analyze the sample data, and then we're going to use our conclusions from the sample data to say something about the population. And that's where we're going, okay? So, but before we get there, we're going to need to create or build up our toolbox with definitions and vocabulary and what they mean, okay? So again, we'll start with the definition of statistics. Again, that's the collection, the organization, analysis, and display of data to draw conclusions about a particular characteristic, which we're going to call a parameter later, of a population. Okay, so the other thing that we're going to talk about, so statistics. That's what statistics is. Okay, that's statistics. As far as with statistics, the other thing too that we're going to talk about statistics is there are two branches of statistics that we're going to discuss. Okay, there is descriptive statistics, and there's inferential statistics. Okay, so what's descriptive statistics? Descriptive statistics is the actual numbers, the calculations that we do on the sample. Those are the descriptive statistics. They're numerical values to describe something about the population. So, for example, the sample mean is a descriptive statistic. The sample standard deviation is a sample statistic. The variance, the mid-range, the median, all of these things that we're going to talk about later that we can actually calculate is a statistic, is a descriptive statistic. It describes something, a characteristic of the sample. Okay, and if we have a good sample, then whatever we calculate for that statistic should be close to whatever the population value is that we're interested in. Okay, what we call parameter of interest. Okay, the other branch of statistics is the inferential statistics, and the connection between these two is that we're going to use descriptive statistics to say something about to do inferential statistics. Okay, inferential statistics deals with probability, okay, which we're going to talk about in chapter 3. So this introduces probability. Okay, so what's the probability? So inferential statistics uses probability and descriptive statistics. Okay, so what is inferential statistics? That's the branch that says, hey, what conclusions can we infer about the population? Okay, that's the connection. So once we have our descriptive statistics, we do our descriptive statistics work and we have our statistics from there, then we can say, okay, well, what can we infer about the population? Okay? Okay, so that's statistics. Now let's talk about the different parts of what goes into the idea of statistics. Okay, so the first thing we're going to talk about is a population. So what is a population? Okay. The population is the set of all subjects, objects, individuals that are under study. That's what we're interested in. Whatever we're interested in, that's the population. So for example, if I wanted to find the average height of all US adults, okay, then the population that I would want to study, the population is all US adults. That's what I want. Okay, that's what I'm trying to learn something about. Okay, so the population would be every US adult would be my population. Okay. Okay, so let's now the next part of that is sample. Okay, so a sample, very simple. It's the subset of a population, some subset of a population. It's a finite subset of the population, okay? So any subset of the population is a sample, okay? That's really all there is to it, okay? Now, let's see, what else do I have written down here? Okay, now going along with sample is what we term sampling. What is sampling? Well, sampling is any method that is used to get a sample. Okay, we're going to talk more about sampling methods in another video. But just so you don't understand, sampling is any method used to get a sample from a population. Okay, so that's sampling. The next thing I want to talk about is statistics. So what is a statistic? So I've used that term several times now. So statistic. Okay, so what is a statistic? A statistic, and so I want you to write this down because when we talk about the next thing, a parameter, you're going to find that the definitions are almost exactly the same except for one change. Okay? So a statistic is a numerical value, so it's a number. It's a numerical value that represents some characteristic that we're interested in for the population, or excuse me, of a sample. Okay? So a statistic is a numerical value calculated using a sample. Okay? So let me say that one more time. A statistic is a numerical value that represents a characteristic of a sample. So it's calculated off of a sample. Okay? So let me give you an example of a statistic. We would use the sample mean, or the sample average would be a statistic. Okay? The sample variance, sample median, anything that's calculated off of a sample. Okay? Now here are the symbols for the different statistics that we're going to be dealing with. Okay? For example, the sample mean or average is represented by X bar. Okay? The sample variance is represented by S squared. The sample standard deviation is just the square root of the variance, which is just S. Okay? And then the median, the sample median is just MED. Okay, so it really doesn't have a distinction. But these are the main ones that we're going to use for the statistics. Okay. Another one that we're going to use later in the semester is R, which is a correlation coefficient. That's where we're going to use that in chapter 12 or 13. So anyway, these are statistics. Now, one thing you want to notice is that statistics are used using regular letters, okay, lowercase letters, okay? Another statistic that we can do, which is a capital letter actually, is R, capital R, which is the range of the data. And then we're also going to talk about mid-range, MR. Okay, these are just symbols denoted, okay? But really the main statistics are going to be these statistics, okay? But as we're going to introduce more as we go on. So again, these are just examples of statistic. The other vocabulary that I want to introduce is parameter. Okay, what is a parameter? Okay, so remember the definition of a statistic. So here's the definition of a parameter. A parameter is a numerical value that represents a characteristic of a population. Okay, so the difference is one word. A statistic is a numerical value that represents a characteristic of a sample. A parameter is a numerical value that represents a characteristic of a population, okay, or a population. So now the difference between a statistic and a parameter, other than where it comes from, is a parameter is usually unknown. In the real world, it's usually unknown because we don't know the populations. Therefore, we can't calculate it. If we knew the entire population, which in some cases we do, if we knew the entire population, then we could calculate. We could actually calculate what the parameter is. Okay, but in most cases, we don't know what it is. Okay. Now the statistic here, we do know what it is. We can calculate it. Okay. Now here's the other thing too about parameters. Parameters are fixed. Okay. Whereas statistics are calculated. Well, they both can be calculated, but are variable. And we're going to talk about this in another video, but I want to introduce the idea is statistics change from sample to sample. It depends on the sample. Okay, so we're going to talk about that later, but they change from sample to sample. Parameters are fixed. Once you know the parameter of a population, that's what it is. It doesn't change, unless the whole population changes, which it can over time, okay? And we'll talk more about that. But in general, parameters are fixed, okay? They are what they are, they're fixed, okay? Statistics are variable. They change from sample to sample. And what do we use statistics for? We use statistics to estimate parameters. In other words, we use them to basically kind of target the parameter. It's our best guess. We want statistics to estimate what the parameter is because we want to target what the parameter is. Okay? So let me give you an example. Kind of bring this home. So we have a population here. Okay, so let's say this is our population. Okay, and so let's say we have some parameter we want to measure. We want to estimate, right? We want to target it, right? So let's say, and again, oh, by the way, let me also add this that I didn't add before. So here's parameters. Here are the different types of parameters. Parameters are always used to represent, let me say that again. Parameters are denoted by lowercase Greek letters, okay? So just like we had the sample mean, sample standard deviation, sample variance, we also have the population mean, population standard deviation, and population variance. So let me give you those. So the population mean is represented by the Greek letter mu, okay? Which looks like a U with a tail. So it's like a kind of a strange looking U. Okay, so we say this is mu, okay? The population variance is used by the lowercase sigma. Lowercase sigma looks like that, okay, with a square. So remember the statistic, the sample mean was x bar. The sample variance was s squared, so the population variance is sigma squared, and the population standard deviation is just sigma. Okay, so again, we're going to go over these more and more in detail. So again, I'm just introducing these to you so you have an idea, so you're familiar with it. Okay, so now let's say we're interested in the population mean. So let's say we're interested in targeting whatever the population mean is here, whatever it is. We don't know what it is. Okay, so the idea is we want to get a random sample. Okay, so we want a random sample, and so let's say we have the sample here, and we measure this sample. So we measure the sample mean, x bar, right? And so what we're going to do is we want to use the sample mean to try to target mu. Because if we have a good sample, here's the idea. So here's the idea behind it. If we have a good sample, then it stands to reason that our sample statistics should be pretty close to the parameter, whatever the value of the parameter is. Okay? If we have a good sample, then we should be able to use our statistic to say, hey, this is probably very close to the parameter, and this is going to be our best guess. Okay? Does that make sense? Okay, I hope so. Okay, so now let's see where we're at here. Okay, let's talk about representative sample. Okay, I've been using this term random sample, random sample. So now let's talk about this idea of a representative sample. Okay, so what does it mean to have a representative sample? Okay, so a representative sample is a sample that has the same characteristics as the population under study. Okay, so let me say it again. A representative sample is a sample that has the same characteristics as the population under study. Okay, that's a representative sample. One of the best ways to get a representative sample is to make sure it's a random sample. Well, what's a random sample? Well, a random sample is any sample where every individual or subject or unit in the population has an equally likely chance of being chosen to be in the sample. Okay, so whatever method that we do, whatever sampling method you employ, if the sampling method allows that all the individuals, subjects in a population are all equally likely to be chosen for the sample, then that's a random sampling process. So in that case, you're going to have a random sample. Okay, so that's the definition of a random sample. Okay, so now what's the best way to get a representative sample? Well, to make sure that we have a random sample, a random sampling process. Okay, so what's an example of a representative sample? Well, think of ethnic background. Okay, think of ethnicity. Okay, that's the easiest one for people to understand. So if I take a population and I know, let's say the population is Illinois. Okay, and let's say I know, okay, and it's very easy to get from census data, that I know what the population ethnic background breakdown is by percentages. And let's say, and again, I'm just pulling this out of the top of my head. So let's say we know that 48% of Illinois is white, and we know that 29% is black, and let's say 12% is Hispanic, and let's say we know that what do we have here? So we got 70, 87, 89, 99. Well, okay, like I said, these, 60, hold on, 60, 77, 87, 89. Okay, this is, okay, 11. That's more, okay, so 11% is Asian Indian background. Okay, so let's see, this is the population breakdown. Well, we want to make sure that whatever sample we get, we should have roughly the same breakdown in ethnicity. That's the idea. If it is, if they're very close to this, then we have a representative sample. If one of the or more of these is way out of whack or really far from these percentages, then we don't have a representative sample. And in fact, that would be an example of what we call bias. Okay, bias is any situation where one group or one group of individuals or subjects is more or less likely to be chosen to be in the sample than other groups or categories. Okay, so if there's not equally likely, then that means there's bias. Okay, so either you have a random sample, whereas all the individuals or subjects are equally likely to be picked, or you don't. If you don't, then that means there's bias in the sample. Okay? Okay. Let's see here. Okay, variables. So let's talk about the different variables in a data set, okay, or in a population. So a variable is anything that's whatever we're trying to measure, okay, whatever we're trying to study, okay. So in a variable, for example, one variable could be height, right? So height could be a variable. Variable is usually, in this case, we're going to start with one population. So in one population, the variable is normally represented by x, okay, lowercase x. Now, so the variable could be height, right? So height is a numerical variable we're going to talk about. So height is a variable. It could have many different values, but the variable that we're interested in measuring is height. Or it could be eye color. Okay? So it's whatever we're trying to measure, okay, that changes. Okay? It could be height, it could be eye color, it could be number of or number of children, that's good one. Number of children in a household. That's an example of a variable. Okay, so now there are two types of variables that we're going to study. Okay, so let's talk about this. Variable. Okay, and so the first type of variable is what we call a numerical variable, or quantitative. Okay, numerical, obviously it has to be a number. Okay, so numerical, quantitative. So numerical variables is anything that's measured using some number. Okay, now under numerical variable, you have two types of numerical variables. You could have numerical variables that are discrete. Okay, what's a discrete numerical variable? Those are variables that only take on whole number values. Okay, so we're talking about 0, 1, 2, 3. So in other words, they're countable. Okay, or what we call countably infinite. It could be an infinite number, but as long as we can count it using whole number values. Okay, so 0, 1, 2, 3, and on. okay? Those are discrete. So for example, numbers of pairs of shoes you own, the number of children in a household, the number of cars you own, the number of people that are on a auto policy, okay? Any kinds of things. The number of M&Ms in a bag of M&Ms, okay? Those are all examples of discrete random variables, okay? Or discrete variables. We'll talk about random in a minute, okay? So another type of numerical variable are what we call continuous. Okay, what is a continuous random variable? Continuous random variables are variables that you can't count. Okay, they're uncountable. Okay, they're also infinite. Okay, so continuous variables are things that usually were described as a range of values. Okay, we can't count them, but we can represent them as a range of values. Okay, so what's an example? Well, temperature. Okay, weights, heights, volumes of liquid, volume. Okay, area. Okay, there's all kinds of examples. Okay, so for example, we can represent the volume of a liquid in, let's say, in ounces from, let's say, 10 to 13 ounces. Okay, well, I can measure. The reason why this is continuous is because I can take any number between 10 and 13 and I can measure that out. As long as I have a measuring device that can measure out to that many decimal places, I can go out as many decimal places as I want. Okay, so I can go to any number between 10. I can do 11.00001 ounces. I can do 11.91836 ounces. I can subdivide this as much as I want. That's why it's continuous. Whereas in discrete, I can only count them in a whole number of values. Like for example, the number of pairs of shoes you own. You don't divide the number of pairs of shoes you own into more than just 0, 1, 2, 3. Okay, does that make sense? Okay, so now, let's talk about the next thing. Let's talk about random variable. Let's introduce the idea of a random variable. Okay, what is a random variable? Well, we know what a variable is, right? Well, a random variable and random variables are usually denoted by capital letters, just so you know. Lowercase letters are used for individual values of a variable. Okay, so lowercase x we would represent as some data set. Okay, so if I had a data set of things, then I would represent as a lowercase x, and then I would have my data. Okay, random variables are represented by capital letters. Okay, just a little nuance that we're going to cover later. Okay. Okay, now random variable. What's the definition of a random variable? It's just any variable where the outcomes or values of that random variable is determined by some random chance process. Okay, so I'm going to repeat myself. A random variable is any variable where the outcome or value of that variable is determined by some random chance process. Okay, so that's the definition of a random variable. Okay, last thing I'm going to cover before we go into our example is data. What is data? Okay, very simply, data is the actual values of the variable that we're measuring. Okay, the variable that we're measuring. So data, which is the plural form, so that's a group of datum. Okay, so data is the plural form, or a single observation or a single value is a datum. Okay, so data is the actual values that are measured of the variable, on the variable. Okay, so that's the data. Okay, so a data set, So a data set is just a collection of all of the data. Okay, So that's like if I have a spreadsheet in Excel and I have all of my data listed in Excel, that collection of data that I have is the data set. Okay, so very simple, very straightforward. Let's see here. Oh, by the way, we can describe data the same way that we describe random variables. Okay, so they can be numerical, categorical. If it's numerical, we can subdivide it into either discrete or contiguous. So we can talk about discrete data, quantitative data, qualitative. Oh, that's another thing I should have said. The other data set. So let's go back to variables. Okay. So now we covered data. So again, data can be described the same way as a variable. So now let's go back to variable. We talked about numerical. Okay. Now let's talk about the other type of variable, which we call categorical. Okay, categorical, or what we call qualitative. Okay, so think of quality. Okay, what kind of quality something has, or categorical, what category does it put in? So categorical data would be data that's non-numerical. Okay, so this would be examples like eye color. Okay, what else? Well, here color, I mean any kind of color. Let's see, type of shoe. Okay, that's one. Type of computer. Okay, anything that can be described in some sort of category. Okay, so we're going to deal with these two later on as far as graphical displays, because we have to handle these differently as far as data. So again, we get numerical data and categorical data. Categorical data is anything that is non-numerical. Okay, qualitative. So understand the difference between qualitative and quantitative when it comes to variables and data. Okay, so now let's do an example. Okay, so here's the example. Okay, again, I'm going to read this off. Okay, I'm not going to write on the board. Again, you can pause this and listen to it over. But here's what we have. Okay, we want to know the average amount of money first-year college students spend at ABC College on supplies that do not include books. So what do? We randomly survey 100 first-year college students, and 3 of those students spent $150, $200, and $225 respectively. Okay, so now, with this example, we want to say, okay, well, what's the population? Okay. This example is also in the textbook too, if you want to follow along. I believe it's the first one, okay, under section 1.1. Okay, so again, we want to know the average amount of money first-year college students spend at ABC school on supplies that do not include books. We randomly survey 100 first-year students at the college. 3 of the students spent $150, $200, and $225 respectively. Okay, so here, the population. Well, what's the population? Well, what's the population of interest? What are we trying to study? Well, the population in this case would be all first-year college students at ABC College. That's the population. That's what we're trying to get information about. That's what we're trying to understand. So the population is going to be all first-year students at ABC College. Okay, that's what we're interested in. The second thing that asks us, what's the sample? Well, in this case here, The sample, remember what a sample is, it's the subset of the population. Well, what is the subset that they're getting from this example? Well, it's the 100 randomly selected first-year students that they surveyed, okay? So that's the sample. The 100 randomly selected first-year students. Okay? And now, the parameter. Okay, what's the parameter? Okay, remember what the parameter is. And here's a little mnemonic to help you always remember what the parameter represents. It's the numerical value that represents a particular characteristic of the population. So remember, P goes with P. Okay? So what's the parameter? Well, what are we interested in? Well, it says we want to know what? We want to know the average amount of money first-year college students spend at ABC College. Okay? So what's the parameter? It's the average amount of money that all students at ABC, first-year students spend. Okay? So that's the parameter. It's right there. So that's what we want to know. We want to know what? The average amount of money first-year college students spend on supplies other than books at ABC College. Make sense? Okay. Now the next one, again, is very similar to this. Statistic. What is the statistic in this problem? Well, remember what the definition of a statistic is. It's the numerical value that represents a particular characteristic of the sample. Okay? And it's also calculated to estimate the parameter, right? So remember, S goes with S. Okay? That's another helpful mnemonic. Okay, so again, statistic is related to the definition of a parameter. Well, what's the statistic? Well, it's the average amount of money of what? It's the average amount of money first-year college students. Which first-year college students? The 100 college students that were sampled. Okay? So, in this, the statistic is going to be the average amount of money the 100 randomly selected students spent on supplies other than books. Make sense? Okay. Now, what's the variable? Okay, so I'm going to erase this and let's continue on. So what's the variable? Okay, so now, the variable in this case is what? What are we measuring? What's being measured? The amount of money that an individual student spends. That's the variable, okay? And that changes from student to student, hence the variable, right? Okay, so the variable is the amount of money an individual first-year student spends on supplies other than books. Okay? That's the variable. Okay? Now, what type of variable is this? Well, we're talking about amount of money, right? Money is numerical. So this is a numerical variable. It's numerical. And now since it's numerical, we can subdivide it. It's either going to be discrete or continuous. Well, we're talking about money. Well, money is continuous. Okay, even though you can only, like, for example, in American currency, you can only go down to the penny, but still, you can still subdivide money. You can do a tenth of a penny, especially with the electronic age. So money is a continuous variable, even though you can only go down to the penny, which is you can count. But be as it may, it's continuous. Okay, so this is numerical and it's continuous. Okay. Okay, now the data. Okay, so data. What's the data? Well, the data is the individual values of the sample, the 100 students. So what is the data? Well, the data is the actual dollar amounts, right? So the data is the actual dollar amounts of the 100 individuals that we collected. The actual dollar amounts. Which 3 of them, only 3, they give us 3 of them, so 3 of them was what? $150, $200, and $225. So again, so this is the data. One of these would be a datum. Okay, so this is a collection of data. This is only 3 of the data, right? But this would be an example of data. The data in this problem is the actual dollar amounts of each individual. Okay, and that's it. So that covers 1.1 of the basics. And then next time we'll go into 1.2 and we'll get into the sampling and things like that. Okay?